this is the Kuji used today for the hands-on exercise on Mercury. The area that we selected is Lermontov crater, settled in the Kuiper quadrangle H6, that was mapped by Lorenza Giacomini. In particular, this crater is 170 kilometers large, mostly, as you can see also by using the tool for measuring the dimensions. As you can see here, it is in meters, but we can convert it to kilometers. Here it is mostly 170 kilometers. Okay. So, oops, I pushed something. Okay, as you can see here, we are visualizing the Mercury Dual Imaging System base map reduced data record. So this base map was acquired using the wide-angle camera on board the imaging system of a messenger mission. We also selected some NAC images, namely the narrow-angle camera images, that if you can display them, please, Lorenza.
Yes.
Okay,
Sure.
they show the floor in higher resolution. And when zooming in, we will do it later, we can observe a better detail of our base map. Then we selected also the enhanced color base map. Okay, as you can see, you observe the surface of Mercury in these colors this morning. This color information Mercury. And in this case, we see bright colors, and we see in particular the orange one that has Anna also said, are connected to faculae. But we can observe also more light blue colors. You can indicate them, yes, that are indicative of hollows, in particular hollows field, as we can see that they are mostly in a compound position, or we can also have isolated hollows when zooming in. Yes, and this is all for the base map. Then we have some shape files for identifying.
Gloria, we miss you.
Okay, so from this point on, it's better if you start talking. This is the indication that my connection is not good enough.
Okay, don't worry. So I think that we can start to see the project. Can you hear me good? Yes.
Yes,
okay.
yes.
So as Gloria said, today we will focus on the mapping of the Lermontov crater. Lermontov is, I think it's a good example of the interaction between pyroclastic deposits and hollows. Since, as Anna said before, these events are quite interconnected to each other. And it should be a good opportunity to see more in detail the different features that we can see, that we can encounter on the on Mercury's surface. So this area actually has been already mapped since it is included in the Kuiper quadrangle map that I've already mapped a few years ago. And if I'm able, I can share the map. Just, I have to interrupt for a minute the condivision and go to the, yes, this one. Can you see the map now?
Not yet.
Yes. Yes, okay. So this is the geological map of Kuiper quadrangle that I perform based mainly on the BDR mosaic. And here there is Lermontov crater. It's located more or less in the equatorial zone. This is the equator. And yes, it's at about 15 degree in the north and at about 48 degree on the west. And as you can see, it's Lermontov crater has been classified as a C2 crater. So it's not very old, it's not very degraded, but it's not also it's not so fresh. It's an intermediate crater. And yes, let's turn, sorry, to the map again. Can you see the map? Yes, okay. So, yes, it's an intermediate crater because as we can see, the crater rim, it's quite neat, it's sharp, there are terraces, so the erosion is not so heavy. Although, since it's quite large, it's a complex crater with it should have a central peak, but the central peak is probably eroded or erased by the possible explosion. There are several pits here. There are some remnants here represented by small domes, but nothing else.
Lorenza, sorry if
Yeah.
I interrupt you. The sharing of the screen is not successful, so we still see a black screen. Can you stop sharing and share again?
Okay, sorry. This one. It's better.
Just one. Okay, yes, now it's working. And I seize the
Okay.
opportunity to ask you if during this presentation of GIS project, if you can also spend a couple of words on the CRS.
This here, okay, yes. So do you mean the
Yes, some people are trying to
the
measure.
projection?
Yeah, exactly. Some people are trying to measure objects on the map and they can't can make the ruler work. So
Okay, okay.
yeah, they
So
will.
if you want to, for example, to measure the diameter of the crater, you should go to this icon, measure line. Click, second click, and you have to choose Cartesian. And you see the diameter, the value of the diameter, more or less 160 kilometer. So I don't know if you see the remnants of the central peak here. So another interesting thing is that Tolstoy crater as Tolstoy, sorry, Lermontov crater as they maintain the ejecta, and this means that are not so old as we said before. Another interesting thing it is that there are several smooth surfaces around the rim of Lermontov, and they are possible melts, pond of melts. The floor of Lermontov are we can see it's quite smooth, and it's possible that they are smooth plains or impact melt, but we cannot say it precisely because as we've seen before, the spectral information doesn't allow us to say nothing because they are masked by the spectral behavior of the pyroclastic deposits. So I think that we can start to map. We can begin to map the first the pits, the possible vents of the pyroclastic deposits, the pyroclastic deposits. Pits, we can map, I can say, distinguish the vents because they are pit, they are depression with no raised rim, so they are, and have more irregular margin with respect to the crater. So as we can see, this, for example, is a crater. This is a vent because it has a very irregular rim, no raised rim. So I think that we can begin with this one, and we can switch on the NAC so we can see better this depression. And so let's start. To map the vent, we have to use the linear feature. So we can toggle the editing and start with this one. And pay attention in this case to the direction on which you want to map. Please go clockwise. So, and I'll show you why later. So we can begin to follow the margin of the pit. Okay. Okay. So we can put certain and type, we can write pit.
Sorry, Lorenza, to interrupt.
Yeah.
I just
Okay.
want to remind the participants that are following the GIS exercise that they need to save this package on their computer. So the output of mapping needs to be saved in a specific folder, as was shown yesterday as well. So in the mapping interface, just please be aware of this. And
Yes. Okay.
Yes, if you can show it, Lorenza, maybe in a couple of steps, it would be nice.
So you can save the project with this save. Is that you mean, Barbara?
In the mapping interface, you need to have.
Yes. Oh, yes. Okay.
Yeah, exactly.
This one you should
Yeah,
press
exactly.
this. Sorry, I have the bar. Okay, and then here you have to choose your folder, the folder where you saved your project. Back to.
Okay, there's one question which I seize the opportunity to read to you, and that's, shouldn't we create contacts in the source contact?
No, because for the linear features, we don't have to use this shapefile. We have to focus on the linear feature. The source contact need to be used when you want to map a unit, a geological unit. In this case, sorry, we are mapping the margin of a feature.
Thank you.
Okay, so we have this this line, and please go to the properties, this shape, file, sorry, color, value, type, classify, and for the pit, usually we choose this symbol. It's 25109 in my catalog. Okay, and this is the symbol of the pit. If before I've said that to go clockwise, so in this way the little segment face inward the pits. If you go in the anti-clockwise, the segment should go outward, face outward. So just for example, we can make a line. I go anti-clockwise. And you can see that the segment face outward, and this it's not what you want. So yes. Okay, so this is the first pit that we've mapped. Let's see if we see other pits. I think, for example, we can go to this larger one. This is a very extended pit, but as you can see, it's quite different from the previous one. Sorry. Because this one is quite deeper and has a fresher boundary, whereas this one is quite shallow and with the margin very eroded. It's quite difficult to see. And probably this is due because they form in different time. This can be an older pit, whereas this one, it is a younger band. So as Valentina said before, the pyroclastic activity can have different events and can occur in different times. So we can start to map this one. So again,
Lorenza,
yes.
I would like to read a question to you. So before starting mapping, there's this question asking, should we invert the colors for of the more detailed pictures of the first pit so that it can matches the illumination direction of the other pictures?
Should we invert, sorry,
the colors of the detailed picture that we use first?
Yes. Oh, well, it depends by you. If you are more comfortable to see the image with a different illumination, you can do it. It's up to you. If you need to do it to map better, you can do it. Personally, I don't need there's no need, but
okay,
it's up to you.
Okay, thank you.
Okay. So again, we have to knit clockwise. An interesting thing, but maybe we can do it later. As you can see, there is also in this bit include also a younger feature here that probably another vent. And in this case, it's possible that this is a compound vent, as Anna said before. So there are possible another events occurred later in the same area. So, but for now we can map the older one. So, okay. They can be useful to also to change the different zoom, zoom in and zoom out, maybe to have a better global vision of the features, and then zoom in to map better the margin. In this case, maybe I can do that, but we can modify later if you're not convinced. Okay. We can map also this one, the younger vents. As you can see, in this case, inside the vents, there is also darker material. And this is possible due to the different material underneath that has been excavated during the explosion, as Anna said before, for the Agu Facula, for example. Let's see if you... This is another vent, very eroded, yes, so quite old. Also here we have not the NAC images, so the resolution are less. I don't know if we've said before, the resolution of the BDR mosaic is 166 meter per pixel, whereas the NAC images here have a mean resolution of 48 meter per pixel. So in this case, I think that we can, yes, we can map it, but yeah, we cannot be so precise. And so you can map it and maybe put approximate for the certainty, and it's something like also here there is a very large pit. Like in this case, we can see that there is an older, very eroded pit, and next to it, a younger vent with more neat, more clear margin. So also in this case, it could be a compound vent. So we can map also this one. So in this case, there are some segments of the boundary that are more neat, more visible. Some other segments are not so easy to see. So I will put approximate for the certainty.
Lorenza, I have a question on the symbol you're using.
Yeah.
So the question is, can you please point us to the symbol library currently used?
Yes.
Is that you're not using the planetary symbols.
Okay, it's possible that I'm using another catalog that I've downloaded some year ago. It's possible. Oh, sorry. I don't know, maybe this catalog has been updated. I use the geological symboling. I don't know if
the library that can be downloaded also, I think, from MAPI. So if the participants didn't see it, it's downloadable and usable through the MAPI interface. You have to open the toolbox in QGIS and install it from there. You can go back to my lesson on the first day on MAPI and QGIS. You have all the detailed instructions, and also the MAPI button has the help, the MAPI interface, where you can see exactly how to do it.
Okay, thank you, Riccardo. Has it been updated, this library, or is still the same? Just to know, just a curiosity.
I don't think so.
Okay.
And since there's another question, I seize this moment to read it to you. They are also asking if there's a scale, a specific scale they should be prepared their mapping for the exercise.
Oh, well, no, okay. Just let me finish this one. Yeah, so in this case, I think that we can put approximate and bit approximate because I'm not sure about this margin. So about the scale, I think that since we are focusing on the floor, I think that a good scale can be Let me see. Yes, this one. So 1 and 50, 500 and 1,000. I think it could be a good scale. Gloria, do you agree with me?
Yeah, if someone else wants to have a better detail, otherwise they can go to 400,000.
Yeah, okay.
Yeah, this is for the WAC image. For the NAC, they can push up to 100,000, but that will stay around 200,000.
Yeah. Okay. Let's see if there are other bit. Maybe we can switch on also the Lermontow, the enhanced color. In this case, we can see that also hollow can help us on better define the pits, because very often hollows occur in the margin of the pit. So this can help on distinguish maybe also the oldest and the more eroded pit. We can map also this one. Let's see another one here. Okay. I can see other possible vents. Gloria, have you seen other possible pits or vents?
No, I think you already mapped all of them.
Okay, great. So we finished to map the vents, and now I think that we can map the pyroclastic deposit originated from this vent. And as you can see, if we use only the monochrome image, we cannot see the pyroclastic deposit. There's no particular surface texture that can help us to map this feature. So in this case, we need to use the enhanced color mosaics. And now you can appreciate the extent of the pyroclastic deposit of the facula. So you can see that there are different shades of orange. Here, these are bright. In this region, the orange are brighter. Here, it's more darker. So probably because near the vents, the pyroclastic deposits are thick, so the spectral behavior of these of the deposit are stronger, let's say. Whereas when you go far from the vents, the deposits become thinner, and so it's not so visible. So I think that for the mapping, we can map only the region that are in a brighter orange. We can be more conservative, let's say. And to map the pyroclastic deposit, we need to go to the source contact. We can use the geological contact. So toggle the editing for this shapefile, and then again we can start to map the boundary. In this case, since there is different the shade of the orange are not so neat. They are not so neat. The boundary are gradual. Let's say, I will use an approximate geological contact rather than a certain geological contact. So okay, start to map. Okay, now I need to zoom in order to be sure that we have the intersection. Okay, approximate or inferred, as you preferred. Okay, and I think that we mapped also the pyroclastic deposit. Yes. So we finished with the pyroclastic, with the volcanic features, and then we can move on to the hollows. Hollows, for this feature, it's better to go with the higher resolution when it's available, because they are usually quite small. They are flat floors, depression. Very often they are small and clusterized. They have bright halos around their boundary. Again, the boundary are not raised, so it can be similar to volcanic vents, but volcanic vents usually are deeper, and the wall of the hollows are steeper, whereas the wall, the slope of the vents are more gentle, but probably the main difference between hollows and volcanic pits can be the color in the non-scholar mosaic. Sorry, as you can see, the hollows as a cyan hue, whereas the pits are usually are orange, because there are pyroclastic deposits on it. So we can begin to to map these hollows. There are, as we can see, there will be clusterized hollows, but also isolated hollows, just so single hollows, larger. And in other case, there will be hollows very, very small and widespread in a larger, larger area. So there are different cases. But now we can start with these clusters.
There's one question concerning the crater floor, and they're wondering whether in the monochrome image, they do see that there is different brightness. So they were wondering if this is related to pyroclastic deposits as well, as in the enhanced color.
Do you mean, sorry?
So in the monochrome image,
Yes, there is a hilar albedo. It could be, but probably this brightness is due to the hollows. Sorry. There are area where the hollows are very small, and we can see just the brightness. And so probably this is the reason why some area seems to be brighter.
Okay, thank you.
Okay, we can map the hollows with the contact shapefile. So this is a small hollow field because different little depression are included. As you can see, there are different little depression inside. This is a single hollows, for example. Can map it. Usually you can see that you can find that the hollows are located exactly along the rim of the crater, of the little crater, like in this case. There are very tiny little hollows. Maybe I didn't cross. Yeah. So you have to modify this one and to go. Okay. And very often you can also, as I said before, the hollows, it's located also along the boundary of the vents. So there is a very strongly interconnection between hollows and pyroclastic activity, as Anna said before. This is a hollow cluster, hollow field, because there are many hollows that go along all the rim of this older pit. Okay, these instead are single hollow. We can map some of these.
Lorenza?
Yes.
Since Viera is pretty full of hollows and also
Mhm.
the ones, maybe for the people following the school, it would be a lot to map all of them. So we could
No,
suggest
yes,
them
sure.
to if yeah. So for this, but when they are too small, especially on the WAC image, the BDR base map, they can map them still as clusters, even if they are isolated ones. Okay, and maybe since we are going to forward the end of today's school, we have 40 minutes left. Maybe we can start moving to other features.
Yes,
Since we
sure,
identified the two most important ones, facule and hollows.
Yes. Yes, it was just to show the different possible cases for the hollows. So we've seen the cluster, hollow cluster, the cluster, the hollows in along the rim of the pits. We can also see in some cases here there are also hollows in how can I say on a landslide that affected the wall of a recent vent. Maybe we can map it. And then also maybe in this case there are a lot of widespread hollows here that can be individually mapped, but it's quite time consuming. So in this case, when we can find very small hollows widespread in a larger, in an extended area, we can map this area like hollowed terrain, for example. And since in this case we are going to intersect the polygon that we made for map the pyroclastic deposit. Since hollow are stratigraphically younger than the pyroclastic, we need to cut this line. So the MAPI, otherwise the MAPI will identify two different polygon. So to do so, if I remember well, we need to go here. Yes.
One quick question. Do the participants have to display single hollows and hollow fields with different colors in the final map?
No, sorry, can you repeat the question? I didn't.
Concerning the hollows, do participants have to differentiate with different colors in the final map, the single hollows and the hollow fields?
I think it can be useful to distinguish the different categories. Yes. So I will suggest isolated hollows, hollow cluster, and hollow terrain. I think there could be three classes that more or less include all the hollows we encountered in this crater.
Okay.
Okay. And yes, there are also here other hollows widespread. So I will map it as a hollow terrain. These are an hollow cluster. And interestingly, hollows occurred also outside the floor. So as you can see also with the enhanced color mosaics, there are more brighter region here that is due to the hollows. If we zoom a little bit, we can see a little depression here, brighter depression here. Yes. So I think we can move on to use mapping. Gloria, do you have other suggestions?
Oh, well, I would say that since we worked mostly inside the smooth planes within Lemordov, we could finish by completing tracing the border of the smooth planes.
Oh, yes, okay. We can map it. Yes. So we can go around the rim. Yes, I go faster. I double click by mistake. Here we go. Okay. So map also the floor. So we can open the mapping tool and build our map. So for the limit layer, we should select source contact. In the indicator points, there should be the source indicator, and in the unit field, the unit name. Again, please we save the project in the right folder, and then we can run, save. Let's see if I made, yes, something. Okay. So now we should differentiate the different source indicator in order to have a different color for the different units. Now I need some help from you, Gloria, because I don't remember very well. So I'm not familiar with the QGIS, I'm afraid. I'm more familiar with the ArcGIS, but we can try to do.
So inside the final map, you can go do a categorization and then classify.
In the properties, categorized, classify. Let's name.
Actually, Gloria, you have to name the points and then you have
Yeah,
to
exactly.
them up.
Okay. Yeah, okay. So
Okay, sorry, because I
Yes.
usually create the points and then I create the map.
yeah, me too. So okay. So this is the I selected this point, and then we can see it's a hollow cluster. And no, sorry, table of content, attribute table. And then we need to toggle editing. And say hollow cluster. Then this one, it is another hollow cluster. Classify the pyroclastic deposits now. Open attribute table. Pyroclastic deposit. Okay, these are, I think they are isolated, yes, isolated hollows. Isolated. So this one. Pay attention to use the same classification, otherwise the MAPI will color the polygon in a different with different hue. Hollow field, a hollow cluster. follow terrain. I filled all the polygon we made. And then I should rerun mapping. Okay. This. Okay, yes. And this is more or less our final map. Yes. Obviously, there are other possible hollows, hollow terrain, so you can play a little bit more. Yes. And yeah, we can also made a layout. Gloria, do you have other suggestion?
Well, from this point on, what we can do is enlarge our map forward the outside. So starting also including the rim of the crater. And we can
Okay.
trace also, this is as
Sorry,
as a unit, as both as a linear feature, we can trace the rim. And then we can move out with including also the smooth planes outside.
Okay, yes. So for the crater rim, we need to toggle on again the linear feature. No, right. For larger certain. West. For larger crater, there is a specific symbol that it's aligned with the two small segments next to each other. Let's see if I can. Here. It's a 25 and 094. Again, in this case, we need to go clockwise when you map the margin. We can also map the crater material that is represented by the wall of the crater. So we move to the source indicator, sorry, the source contact.
Lorenza?
Yeah.
Yeah, it looks like I thought it was a problem with my computer and my connection. Maybe you can recharge the mappy so that it uploads the final colors. Yes, that tool.
But there is the final color already.
Oh,
Follow it.
so you see the also pink and purple ones?
Yes, it's quite small, but
Okay, okay.
There,
Okay, because okay, thank you.
yeah, okay.
Because from outside I can see only orange and the yellow one.
Oh, yeah, because they are quite small, so we can also choose another color, so it's more visible. Maybe green, who knows? Yeah. Yeah, but we have already another light green. So blue. Yeah. Okay. We can map crater material, the crater wall. Sure, you can intersect. So I've intersected the all the line, but we can see now with mapping. Oh, yes, okay. So we need to classify also these points, the source indicator. Here.
Lorenza, I have a question. Someone in the chat is wondering if the main unit then on the floor is pyroclastic deposit, as it's appeared to be all orange, almost all orange, or
Sorry, can you repeat?
yes, in the crater floor, the biggest unit appeared to be the pyroclastic deposit, and they were wondering whether this is the case or it's just
Yeah, yes,
base
most of the floor are occupied by pyroclastic deposit, yes.
Okay, thank you.
Material. Okay, so now I have also classified the crater wall, and then we can finally map the little melt pond here. So there's contact. I'll go there. Can map it. I will go a little bit fast, just to have an idea. So here there is a very small font. This one, I think it's the last one. Yeah, there's also this one. Oh. We run the mapping. Okay. And we can classify the point. That point. Would be faster. We can just see here, which is the lacking. And then, okay. Okay, I think we can move on to the layout. So, project and new print layout. Now we can choose a name. I will choose Lermontov. Okay. So we can add the map with this icon. Okay. And we can zoom in with this icon here, and then also, yes, to move it.
Lorenza, we don't see your screen. Maybe you're sharing just the QGIS application, and this is why we don't see.
Ah, okay, sorry. Okay, so this one. Okay, I go to the layout, and then okay, let's start again. We can choose this icon, add map, make a square, and then the map will appear. Now with this icon, we can zoom and shift and move the map as we want. And then we can add also the legend with this icon. Okay. We can delete the thing that is not interesting for us. Let's, for example, delete source indicator. No, I cannot. No. It's not possible to delete some items in the legend. I cannot do anything. I don't know why. Ah, so sorry. I need to deactivate the auto update, and then I can modify. So source indicator. And all the database, NAC, BDR. Yes, I forgot to classify the contact, so I need to Can you see my screen? The map, the project with the map.
Yes.
Okay. So we need to go to the final contact. Please categorize, classify. You should go to the certainty, classify, certain. There should be also approximate, but I don't know why there's no approximate. Maybe because yes, I put some approximate contact, but it doesn't appear in the final source contact. I don't know why. Do you have some idea, Gloria or Riccardo?
I remember that you traced approximate for hollows, but
No, for the pyroclastic, I remember, but maybe I've made some mistakes, surely, for sure. Okay, I don't know why. Maybe some mistake here. Well, all the contact are certain. It's not, but you should see also the approximate. I don't know why it doesn't work, but yeah, there should be the two different contact. Anyway, we can go again to the layout. Sorry, I need to recondivide the layout. Okay. And yes, maybe the legend. The title. Okay. Maybe we can. Okay. I think it's all. We finish in time.
One last question concerning units, and they're asking, shouldn't there be also a smooth plane unit in the crater and only the pyroclastic deposits?
Yes, smooth, rather than smooth plane, I will say smooth material, because we don't know if when you classify a terrain as a smooth plane, you are saying that there is a volcanic deposit. There are lavas, but since we are not sure about it, I will stay more general. So I will classify the floor as smooth clutter floor. So it could be impact melt or surface or smooth plane, since the pyroclastic deposits masks all the information. We cannot be sure of what material there is in the floor. So we stay more general as possible.
Since we arrived to the conclusion of this exercise for today, I would like to say, and Lorenza agree with me if you if we are on the same page, but in this case we did a map that it was an example for the participant to understand how to map this area on Mercury. We did it a bit faster, maybe. Okay, so we would expect a map that includes also the area outside of a crater, where there are also the ejecta, so beyond the smooth melt ponds that you found, but also a map that does not contain empty areas. So there should be all colorized with a unit.
Yes, all the crater should be classified. All the units in the crater should be classified.
Yes, yes.
Okay, thank you so much. I think
Thank
we
you.
are at the end of this morning session. Thank you to our lecturers today, Gloria, Tognon, and Lorenza Giacomini. I just want to draw your attention to the fact that the Q&A may stay open. So if you need confrontation with some of other participants, please use it. Feel free to use it. And for this afternoon, there will be a series of seminars dedicated to Mercury. But please be aware they will not be in the Mercury room, but they will be held in the seminars room. So please make sure you connect to the correct room this afternoon. And I think we are, there are a couple of questions maybe. There's a few questions. As we have 2 minutes, I would like to read them to you and then we can close. So there's just a little confusion concerning what do you mean by saying no empty areas? So is these empty areas must not be just within the craters or in the entire portion of the map that they decide to map? So what's happening for the units outside the rim?
Gloria?
Okay, so in this case, I was referring, if you, sorry, I don't think I see the updated map because of my connection, but if you can zoom into the southeast of the map, for instance, where is the contact between the crater material and the melt ponds, and I can see it.
Oh, yes.
showing it, there should be like an empty area between the two units. What I meant is just that we would expect to see a map that lacks these empty areas that we didn't map just because of the lack of time right now. Okay, so there should be in any case, like, let's say, like a background unit.
Yes, for example, ejecta. You can
Yeah, indeed.
trace the boundary. I think that the ejecta occupy all the area, so we can make a square and then classify it as a ejecta, crater ejecta. It's quite easy and fast.